Okay, let's go back to year 10, where we had your first encounter with trigonometry. Let's call that A, let's call that B, let's call that C. You know that sine theta is opposite over hypotenuse, and you know that cos theta is adjacent over hypotenuse. You also know that A squared plus B squared equals C squared because of Pythagoras. So let's take this Pythagoras equation and divide everything by C squared. So A squared over C squared plus B squared over C squared equals 1. But A over C is sine theta, so A squared over C squared is sine squared theta. And similarly, the fact B over C is cos theta, so this is cos squared theta. So then we get this identity that we used in the C2 exam. Let's take this, let's now divide everything by cos squared theta. So I'm going to get sine squared theta over cos squared theta plus 1 equals 1 over cos squared theta. Now, strictly speaking, I should have used equivalent signs here. Let's just put those in here. Now, sine over cos is tan, so sine squared over cos squared, that must be tan squared. And 1 over cos is sec, so 1 over cos squared is sec squared theta. For some reason, this is often written the other way around. 1 plus tan squared theta is equivalent to sec squared theta. So this was an important identity in C2, and this is an important identity in C3. Now, previously we divided by cos squared. Let's divide everything by sine squared. So sine squared divided by sine squared is 1. So we get cos squared divided by sine squared, and that's equivalent to 1 over sine squared. So therefore, well, sine over cos is tan, so cos over sine is 1 over tan, but 1 over tan is cotangent, cot. So it's 1 plus cot squared that equals 1 over sine squared. Well, 1 over sine is cosec, so 1 over sine squared is cosec squared. So therefore this is the second important trig identity that you need to know at C3. Now here's another of these pesky trig identities that we need to prove. So let's start with the left hand side. The left hand side is cosec fourth minus cot fourth. So we can use the difference of two squares to write this as cosec squared theta minus cot squared theta multiplied by cosec squared theta plus cot squared theta. Why is that? Because cosec squared times cosec squared is cosec fourth, minus cot squared times plus cot squared is minus cot fourth. That term, minus cot squared cosec squared, and this term plus cot squared cosec squared cancel out, so it's a difference of two squares. But we do know that 1 plus cot squared theta equals, in fact, is equivalent to cosec squared theta. So because of that, we can say that 1 is equivalent to cosec squared theta minus cot squared theta. So cosec squared theta minus cot squared theta equals 1. So this lot equals 1. So therefore the left hand side is equivalent to 1 multiplied by the cosec squared theta plus cot squared theta. Now I've got to somehow get that into this format here. Well, one of the techniques, if you're not sure at this stage, is just to write everything in terms of sine and cos. It doesn't always work, but one technique, if you're not sure, is to write everything in terms of sine and cos. Cosec squared is 1 over sine squared, and cot squared is cos squared over sine squared. Now with these trig identities there's a number of techniques you can try, and writing everything in terms of sine and cos is one of the things you can do. So at this stage we've got sine squared at the bottom there, sine squared at the bottom there. That's not a very good 2, but that's meant to be sine squared. So let's write everything with a sine squared at the bottom. So we've got 1 plus cos squared over sine squared. But what is sine squared? Well, sine squared, another way of writing that is 1 minus cos squared. That's since sine squared plus cos squared equals 1. So this equals the right hand side, therefore proof complete.